Hello, right, good morning to attendee list. My name is Alex Fielder and I'm an application engineer here at Graitec. I've been working here about a year, just over a year now. This morning I've got my colleague Paul Munford with me helping answer questions, so if you have any questions then do please use the chat box or the questions box here in the GoToWebinar software. Just give it a few minutes, get some more attendees into the list here. I know we're a bit sparse on numbers, but we'll give it a few more minutes. We're just a little bit ahead of time here. Right, so before we delve into the details and specifics about Inventor LT, let's talk a little bit about Graitec. So Graitec have about 30 years in experience in the CAD industry as a platinum reseller of Autodesk software. We have 26 offices worldwide, 5 UK sites in Southampton, Milton Keynes, Nottingham, Bradford and Durham. So what does this mean to you? We've got a worldwide technical team. We've got the capacity to specialise within various areas of technology, from digital prototyping to building information modelling and everything in between. So I mean, as an example of the international presence, just I think it was a couple of weeks ago, had a email chain with an Italian colleague talking about iLogic within Inventor. So today's agenda is initially I want to talk about some of the features that you get within the Autodesk Inventor LT. So these are DWG Underlay, which is useful if you have legacy 2D CAD data that you perhaps don't have the time to recreate in 3D from scratch. Import and export of third-party CAD data. Perhaps a supplier says I need a widget that fits this component and provides you with a 3D model of the component they want to fit something to. Now historically this would have to have been a step file, a 3D step file, which would not be able to update if the customer changed something. Inside of Inventor LT now there's an updated functionality called AnyCAD. I'm going to show you how you can easily turn these provided or downloaded models into an Inventor part file and subsequent drawing. So using that converted third-party file, I'll then modify it using the direct edit functionality available with Inventor LT 2017. And then last but not least, how any updates you may carry out to those designs, or modifications, sorry, will filter down through to the Inventor drawing environment. So let's dive straight into oops, I might come back a page. That is right, actually. Let's dive into DWG Underlay. So what does it mean to you? You get to reuse legacy 2D data. With this it means you don't need to redraw any geometry from the original drawing. Once you've selected a DWG file to work with, you can easily orientate the geometry you wish to reuse, and actually lastly in there you can get the ability to crop the DWG data to the specific area you're interested in. Crucially, because Inventor LT maintains a link to the original inserted DWG file, if that file were to be updated for some reason, so long as nothing is deleted, none of the line work, the geometry is deleted, the geometry inside of Inventor will update as well. So let's take a look at a quick demonstration of all of these things. So I'm just going to dive into my Inventor LT window. So if I look at AutoCAD quickly first, this is an old drawing file I've had in my I suppose my Dropbox, I guess, is where it was, where I found it actually, for 5 or 6 years now. This is just a simple couple of shapes here. There's 2 versions of this. So currently this is 10 millimeters wide, and if I go into Inventor LT, I can make a new part file, and this anybody that's seen Inventor will recognize this ribbon straight away. This is identical to the part modeling ribbon that you get inside of full Inventor. So inside of here, I'm going to inside of my new part file, I'm going to click import, and I'm going to go to companion cube and to open that. I'll pick a work plane to place this onto, in this case XY, put my insert point in, and I get a message that says inserting an AutoCAD DWG creates an associative DWG underlay, and it says you need to use the project DWG command, DWG geometry command, to create associative model features based on the projected geometry. I click OK to that because I accept that that's what I want to do. I then start a 2D sketch on that same work plane, and under my project geometry tool I have this project DWG geometry button, which I can click, and I can click on my shape here. I'm only going to do the small one of these, and you'll see why in a second. So this is just a simple piece of geometry. I have got this other bit around the outside here, but if I just cancel that tool, the yellow lines here now are projected from that DWG shape. I can finish that sketch, and then I can actually use the crop tool, which I spoke about just now, to draw a rectangle around that geometry. And OK that, and it hides away the larger shape. What's going to happen is I'm going to go back to AutoCAD now and actually resize that. So in order to do that, I need to actually delete the crop out of there. Otherwise, when I resize, it's going to crop the geometry that I actually want to use for a solid. So I'll do a solid first of that shape, and pick my, oops, make sure I get the right profile. So that's the shape I want. I want it to be 10 mil thick, but obviously I need to make this larger. This is it's designed to be, the larger one there is designed to be a coaster, and this one's supposed to be a keychain. But I'll just do an extrusion of that for 10 mil for the time being, and OK that, and I can save that part file as AnyCAD example. I can return to AutoCAD. I've got that same DWG file open, and I've got the dimensions on here to show you that when I scale with AutoCAD, and I'll just use a arbitrary base point, something like that. If I make that a scale reference of 10, it resizes my geometry, and the dimensions obviously change to suit. If I do a save of that file and pop back into Inventor LT, I get an update warning at the top of the screen here, and obviously my drawing here has got a little lightning flash on it as well. I can click update, and that resizes. So I think you can see from that, if you have legacy 2D data that you don't have perhaps the time to redraw, to remodel from scratch. I mean, that shape, there's quite a lot going on in that. It'd be quite a complex sketch for Inventor to, for an Inventor user to put together. If you need to just get something machined quickly, perhaps. Yeah, so if you have legacy 2D data and you don't want to go down the route of redrawing it straight away, perhaps, this is a really good tool for getting that geometry into a 3D model. I'll just quickly go back and crop this this DWG file here. So if I crop that away, that goes away, and I can do anything to this that I would normally be able to do. So I can put a sketch on here, put a point in here somewhere. I'm not going to fully constrain that just for the demo of this. So put a hole through, make that like so. So if my DWG geometry, I want to reuse old drawings perhaps, you can pull that through. I have another one I can quickly just, another file I've got here I can quickly show. So again, open a new part file, import, and it's called balance plate. Insert that into the origin, like so. And if I do my same steps again to make a new sketch, actually I'm just going to pop back to that and just demonstrate how you can move that around. This has been updated for 2017. I've been training full Inventor users this week, and they didn't have the translate tool was in here. It was a little bit more difficult to use. If I pop that onto there, it snaps to the 00, to the origin of this part file. I can then go into my sketch, project my geometry again, and do that. Do the whole lot in one go. That's project connected geometry option. If I just do that, then these holes I can put in. If I just do that and that, I'm not going to use the profiles there as my for my holes, because I want them to be holes. I also can project in this geometry here of just that thickness. I can do that as well. And then what I can do is place a dimension on here, and this will be a reference dimension, but that's fine because I want to be able to use that dimension there in my extrusion. So if I just go back in here and turn that to construction, and that also to construction, gives me that shape. And rather than writing in the dimension there, I can use the parameter that I've already created with that dimension, and do just what I want. I can then use reshare my sketch. Sorry, share my sketch, and use my hole tool to. I could have projected in the and put a diameter dimension on that, and it would be 40. So I made that a little bit hard for myself this time, but that's 11 through, and that one is 40. I've missed off the points on the back here, but again, if this geometry was to update in AutoCAD, the Inventor will recognise that there's been a change, and there'll be an update available. So that's a quick demonstration of DWG Underlay. I hope you can see the potential usefulness of that. Pop back into here a second. So now that we're happy that our legacy 2D data is working as expected, it's time to think about those situations where you might be working for a customer and they may currently provide you with a 2D paper drawing to work from. Now, with Inventor LT, you'll be able to request a 3D part file. Over the course of the last two major releases of Inventor, Autodesk have put in place some major under-the-hood additions to the toolset available when working with provided 3D models. This functionality is known as AnyCAD, and with this latest release we see the inclusion of AnyCAD 2.0. The main change between this and the 2016 release is the inclusion of a reference option for step files. This means that whereas in the 2016 release you could only convert this file format to a part file, you now have the ability to create a reference back to the source third-party file. So much like the DWG Underlay functionality just discussed, if the customer sends you an updated step file, Inventor can see there's been a change and will prompt you to update accordingly. So let's just take that's the slide for that. So yeah, the additional functionality is the step file referencing, and then amendments to provided reference parts update through to your model. So let's pop into an example of that. So if I look in my folder here, I have a where's it gone? It's hidden. So this is a part file. This is this file here on my screen is a SolidWorks part file that I downloaded from grabcad.com. I'll go in here and I'll make a new file, new standard part file. I can then use my import tool. In this case, it's going to convert the model. So the reference option there, reference model option, maintains a link to the selected file. If, however, I can just click on OK on that, and it will sit there and convert that quite rapidly. Once that completes, you'll have a surface version of that that part file. So there's my Chinook on my screen. If I turn that off at translucent, you can see the model there. This is actually a model of a I think it's 1:10 scale model of a Chinook. That's one option. That actually converted that for me. If I say, however, open, and I select SolidWorks files. Not that one. Why did that? Again, this is going to convert this, and this is because this particular model is actually an assembly. It has components in there. So one of the limitations of Inventor LT is that it only works with part files and drawings. It doesn't allow you to build assemblies or constraints or have bill of materials. So when I was asked to look at the webinar, I'm an Inventor user at heart, so I've been using Inventor now for nearly 8 years. I was asked to take on the webinar as a colleague had left, and I was kind of thinking, well, why would you pick Inventor LT over going full Inventor? Historically, Inventor LT would have been a lot cheaper than Inventor. With the move to the rental situation, that's even more paramount. The prices of these products are constantly changing, so if you are interested, then do please contact our Graitec sales team. And I say that I was asked to take on this webinar, and I thought, well, why would a company move from 2D to LT, to Inventor LT? And I say that the cost of these things historically have been quite high. And what a customer of ours does currently is we sold them a full license of full Inventor, and then we've sold them on a rental agreement some licenses of Inventor LT. So what that means to them is they can take any 2D data they have and have a team of people, maybe they might be interns or students perhaps, that they have come in and they do just some basic part modeling in Inventor LT, and then the single user license of full Inventor is used to turn that into assemblies if they need to. Inside of Inventor LT you can create drawings, you can do all of the part modeling steps that you can in the regular Inventor environment. You just, as I say, don't get the ability to create assemblies or constraints and bill of materials. So if I just go back to my presentation. So once you've got your basic reference files up and running, you might be thinking what you can do with them, how you can modify them perhaps. And with the tools built into Inventor now, you get direct edit and freeform functionality. And what that means is, if I've got a file here that is a assembly file. There's an assembly file there which I can't open with Inventor LT, but I've got a part version of it, which is this one. So I can open that with Inventor, and I go to here. Assembly CAD Freeform. Once that opens, this is a CAD for a digger, I guess. So you might want to put a handle on this gear stick here on the top, like a grip, a bit like this one that's here already underneath the seat. So you may have the geometry available for that part, just the basic sort of shape. So this is just going to quickly demonstrate the freeform capability. So leave a handle. So once that loads, I think it's loading. What was that doing? Come on. There we go, finally. Right, once that's loaded, this is just a basic Inventor part that has a threaded hole in the bottom. So this would effectively screw onto here. I can't put that into that part in Inventor LT because it, as I say before, it can't work with assemblies. But what I can do in here is I can create a freeform. So I can create a cylinder, and the radius needs to be 25. Height is let's go with 100 to start with and see what that looks like. So I click my face, click and drag that up, and if I say that needs to have 8 faces, it makes it a much smoother shape, and it's locked to the center of that end of that bar that I just had, the simple extrusion with a hole in, and I can start to sort of push and pull that using my freeform tools. So if I OK that, I can then pick 1, 2, 3, 4 and actually tell it to edit the form, and then I can use my translate tool to push those in and give me a kind of a finger grip space. And I can OK that, and I can pick with a simple selection box like this, that entire edge, and I can basically squash it like so. Oh, one thing I did forget to do actually was turn on the symmetry. So if I just undo that a second, I did actually rush into that, so let me just delete that and do that again. So cylinder, that on that edge again, so radius 25, height 100, face is 8, and the crucial thing was the Y symmetry, so what I do to one side will affect the other. So I'll pick those points again, so 1, 2, 3, 4, edit form, give them a bit of a push in, like so, and that gives me a bit of a grip shape. I can OK that, and this is why the symmetry was crucial, which I forgot when I did this just now, is drag that box down there, edit form again, and this time it's going to squash the entire thing, which is exactly what I wanted. Now, I suppose you could do a handed version of that perhaps, given where it's going to potentially be sat inside of here, unless you're some kind of contortionist, you're not going to be able to get that, reach that hand, I guess as a gear stick with your right hand. So you could actually forget the symmetry on there altogether. Just do it on one side to squash it in. But with that tool, with the Freeform there, you get some really powerful functionality. Insert edge, subdivide, etc. So if you're kind of working on an ergonomic style product, or a consumer product, perhaps maybe it's a kettle or something for the home, like a speaker perhaps, the Freeform tools in Inventor LT are really powerful. So it's well worth checking it out for that alone. So we've looked at Freeform. Let's see what happens when we start to look at editing files and how the updates and things take effect. So just to recap on there, the direct edit in Freeform allows you to make changes to reference 3D data, to quickly add, edit or remove holes and features. Easily create freeforms that match the desired shape. So in terms of updating your designs, with Inventor LT, the parametric element of Inventor means that if you change a dimension, a parameter, the updates are instantaneous. The updates filter through to drawings, and as I've already said, if other users have full Inventor, updates filter through to them as well. So let's take a look at some couple of files that I've put together for this. So I'll pop back into Inventor once more. So I have a file that I use for my training classes, and it's this little part here. This is a quick drawing I've kind of edited just this morning just to put this together. If I actually open that, here it is in my Inventor modeling window. This is just a basic Inventor part. It's a revolution, extrusion, a mirror, revolution inside of there is a cut, a couple of holes, and a thread in the back of the hole here. So if I make a change to this, if I put a chamfer on this back edge, make that 1 mil, I can sketch on this face, and I can use my projector tool to project in the centre there. If I select, draw some geometry on here. Because I use this for my training, I know this part inside and out, so I know that these lines here need to be 16 apart. That, actually I should be able to cheat and do this. So that should equal that, that should equal that, and that's it locked down. Those are actually on the drawing I've got, the drawing I give to my students, those are 8 mil apart of the centre line, just for a reference there. So I can make that change, and I can do an extrusion of those two parts. They are 8 mil long, thereabouts. And if I sketch on that face, use my line tool, put in a line that gives me my hole spacing, so I know that it's 24. Select that and turn it into construction geometry. Pick my endpoints, turn them into center points. Center points there mean that Inventor will treat those as holes. All I need to do then is say that it is, if I check the center point in, and that needs to be 5. One thing I've forgotten actually is a constraints. So all of these tools are exactly the same as the part environment you get in full Inventor. Like that. So that's locked down. I can use my hole tool, put a hole through, and the pause here is Inventor loading the exact same thread table data that the full Inventor can reference. So once I change that to isometric, it will, in the list at the bottom, excuse me, should change to M3. So we'll do an M3 full thread. It's not going to preview it just yet, but it should do that. So with those small changes, there's a chamfer, extrusion and a hole. My part drawing here instantaneously updates to reflect that change, which I think you can see is a massive time saver. The other thing that this approach allows me to do is I've dimensioned this this part in the part environment. Just close that a second. So inside of my sketches in the part file here, I've got a bunch of parameters, and a couple of these I've actually applied tolerances to. This one in particular, I've applied a shaft tolerance to it. So if you've worked in engineering for any period of time, you'll have hopefully seen ISO limits and fits, and that's what this is. That's what this option here is. This gives you all of the available limits and fits that you might ever possibly come across in terms of shafts and holes. So I spent the time to put that into this particular sketch because by and large, when you create a drawing, you will always have tolerances included, whether there be a global tolerance note or individually toleranced dimensions. So if I just delete that, now you can put a dimension on here manually, like so, and then you can apply a tolerance. So limits fits, show size limit, change it to G6 perhaps. So we know that's going to be smaller than our 38mm nominal size. That's an extra couple of clicks that you can actually do away with if you make use of a tool in here called Retrieve Dimensions. So I'll run the Retrieve Dimension tool, pick my part. It will display a whole bunch of the sketch dimensions that the part is defined by. I'll just pick that one that I've just changed in the model there, and then click OK. And you can do that for not just this view, you can do that for any view that is referencing that part. So I can do it on here as well. So there's some dimensions inside of here that I'm going to grab quickly. So you've got two methods for getting that. You've got the right click on a view or the retrieve option up here. Select my view, select my part, in this case this one, and then I'll go in and just grab 1, 2, 3, 4 and 5 dimensions. And that's way faster than having to redimension those. You just then just drag them around to line them up. And when I showed this to my Inventor trainees this week, they were oohing and ahhing at the speed with which that gets you a drawing. You don't have to try and grab the right edge or try and click on the diameter here to pull out the diameter, and maybe have to add a diameter symbol. The best thing about this dimension here is that once they are retrieved, you get the option to edit model dimension. This one's actually a sum. I'm going to actually delete that and make that 19, and that will resize that straight away. Similarly, I can make that, oops, because I've retrieved it, I get the option to edit model dimension. I can make that 14, and it makes it smaller. So it's really powerful functionality. say any changes you make to a part that is referenced by a drawing, in the case of Inventor LT, or if you were working in this environment where you had a team with a limited number of full Inventor licenses, any changes you make to the parts that are referenced by those assemblies they might be using, or assembly drawings even, in full Inventor, the updates will proliferate through the entire data set. So that brings us to the end of our webinar. And if you want to learn more, you can go to the links here on the screen. I don't think we've got any questions in the list there. So what did we cover today? We talked about DWG Underlay and the ability to reuse 2D legacy AutoCAD data. We've talked about importing of existing 3D CAD data, so whether it be step files or, as my example there, a solid part file. We've touched on Freeform functionality, and lastly we've talked a little bit in depth there about taking a design, updating it, and seeing the drawing go from what it was to what it was updated to. And then lastly we kind of touched on the ability to quickly reuse parametric dimensions from within the sketches that define those part files in the drawing, and the added ability to actually potentially modify those in the drawing space and have it pushed back down into the parts. So yeah, thank you to everyone for attending to today's presentation. And if you'd like to learn more, you can give us a call on our number. My name's Alex Fielder. This has been the Inventor LT versus 2D webinar. Thank you very much.